Okay, so hi everyone again. I am Chard Aye of the Liceo Math Club. This day we're going to talk about finding the difference quotient of a function. Okay, so this difference quotient is the introduction before you could even go to your basic derivatives. Actually, this video should have been before Jetman's video on basic derivatives. Nonetheless, we will tackle that here. Okay, so the difference quotient states that your f prime of x, this is your, actually, f prime of x is your limit of f of x as h approaches 0. So as h approaches 0. Okay, so this limit of f(x) as h equals 0 is equal to your f prime of x. Okay. You will know this in the future as your y prime or your first derivative. Is equal to your, we have a long kind of expression here, f of x plus h minus f of x all over h. Okay, so we're going to solve the difference quotient using this formula for now. So one example will be, say you have a function in the form of f of x equals x squared plus 4x plus 4, say for example here. So what is the difference quotient, or we could just simply denote this as f prime x. F prime x. Okay, so we're going to use this formula in this example over here. Okay, so let's start. We're going to get first the f of x plus h. Okay, so it's even better to get it by parts even before we should put it in the formula itself. Okay, so let's have first, since we are required to find the f of x plus h, we need to find it first. Okay, so we'll find first the f of x plus h. So in your evaluation of functions in your GenMath, you know that if x here is changed into something, okay, all the x's will also adapt to that change. Okay, since your x's became x plus h, so these two x's here will become x plus h, and then simplify. So what we have is this x will become x plus h. So what we have is x plus h squared. Simply this x becomes this plus your 4 times your x plus h. Okay, copy the concept number 4. Okay, so I think here we can simplify. You can watch our video in in factoring. How can we express this? We'll multiply this first, x squared. Okay, so we can multiply this then x times h times 2. So this becomes plus 2 hx. Okay, and then h times h is gonna become h squared. So this is the trinomial from this binomial being squared. Next is this one, so we will distribute this 4 both to the x and to the h. So this will simply give us 4x plus 4h. And then copy the 4 here since it's our constant. Okay, so this is our f of x plus h. Okay, so if we can simplify anything here, so we should, since we cannot simplify anything, so this is it. This is our f of x. Okay. Notice our f of x is this one. So how can we make things better here? This one, this f of x plus h, and this f of x of ours will substitute this one in this form minus this f of x in this form. Okay, all over a denominator of f of h. It has f prime of x is equal to this long function here. So we have x squared plus 2xh plus h squared plus 4x plus h, or 4h rather, plus 4. Okay, so after doing this, this is just our f of x plus h. Okay, notice that. We're going to copy the minus sign. Okay, copy the minus sign. I think we need to extend it here. And then copy our f of x. Our f of x is this. So just copy the right hand side of this function. So what we're going to put is enclosing the parentheses, that's very important. X squared plus 4x plus 4. Okay, this will be all over the denominator. What will happen then? This minus sign here will be distributed with each of the terms on this parenthesis and this will be. So we're going to distribute this minus sign here, and minus sign here. If that happens, I think we can just simplify this line here. And this x squared will become minus x squared. This positive 4x will become negative 4x, and this 4 will become negative 4. So by deleting this and changing it to the correct form, what we will have now is gonna be minus x squared minus 4x minus 4. Okay? Now in this part, we can cancel out common things. Okay? On this part. So we can see that we have a negative x squared, we have a positive x squared here. We can cancel this out. Make that 0. We have a negative 4x, and we have a positive 4x, we can cancel them out, and we'll have 0. With just one item. And we have a negative 4 and a positive 4 here, so it becomes also 0. And what is left is the one we're going to work out in the next line. Okay. The next line here will be whatever is left. So we have here 2hx plus h squared plus 4h. Now if we can, let's put that in the correct proper writing in algebra. So we have h squared plus 2hx plus 4h. Okay? And then we're going to copy the denominator of h, of course. Now after this, we're going to get the common monomial factoring. You can revisit our video in the factoring sections, factoring terms. You can see here that there's a common factor of h. This has an h. This has an h. This has an h. So we're going to get that common factor out. Okay. So what will happen is there's an h here outside. If we're going to get the h of this h squared, this will become just h. Right? Next, if we're going to get the factor of h here, this will just become 2x. And if we're going to get the factor of h here, this will just become plus 4 all over h. And this is the moment where we will cancel the h in the denominator. Okay? Simply we can just cancel it since it's a factor. Okay? After cancellation, we will be just left with this expression then. This one. H plus 2x plus 4. Okay, and then one last thing before we could make this our final answer. Recall that our difference quotient is equal to the limit of f of x as h equals to 0. So from your limit formulas, if you approach something, okay, the shortcut in doing this is substituting that something, this h here, in whatever number it's approaching. That's your shortcut, okay, for the limits formula. So since h approaches 0, you can just substitute h 0. So if you do that, since we know the limit of f of x, what's gonna happen here is h is gonna approach 0, so this h will become 0. So simply it will become 0 plus 2x plus 4. Or if you just delete that 0, what we'll have is 2x plus 4. And this is then your f prime of x. Okay, and that finished our video for the first example. Hopefully we're going to make a lot of examples for this difference quotient. And yeah, thanks for watching.